Hi. So previously we talked about the production theory, and we defined the basic components that we need for studying the production theory, which is the production set, right? And we also showed the production function and the connection with the transformation function, right? So today we're gonna take a step further and discuss the profit maximization and cost minimization problems. Okay. Profit maximization and cost minimization. Okay. So we call this as PMP, profit maximization problem, and cost minimization problem, CMP. Okay. And you can see that those are also dual problems. And as we just said, we talked about previously in the consumer's theory, right? Okay, so again, we're gonna have our dimensions. Okay, so our goods to denote this the price vector. Okay, and so this P will be a price vector including a tuple from P1 up to PL. Okay, and all those prices there are positive numbers. Okay, so and we're gonna assume that the firm's objective is to maximize the profit, right, or minimize the cost. So as before, so we normally assume that the firm's production set Y, we have the non-emptiness and closedness and free disposal. Okay. All right. Good. So for the first one, let's talk about the profit maximization problem. Okay, so given a price vector P and the production vector Y, okay, so the profit generated by some firm by implementing this little Y, okay, that'll be this P inner product Y, right? And that'll be just a summation for all those dimensions. Okay, so, and intuitively, that is the total revenue. So this is already, be careful that this is already the profit, okay? This is not revenue. The reason is that this is already including the positive revenue and the minus cost, okay? Is this, okay? Including the total revenue generated by the positive amount of products and minus the cost, which are taking the some cost or some prices for this inputs, right? Okay, so then we know that we have some technological constraints that we can produce or taking some input to get some output, but this has to be constrained in our set capital Y, right? So that'll be our constraint to this problem. So this PMP formally, it is maximizing by choosing some little y. The objective is to maximize the inner product of P and Y. Okay, and the only constraint will be this little y has to be an element of this capital Y. Okay, or equivalently, we can use the transformation function. So it'll be maximizing also by choosing some little y, the same objective, and the constraint will be using this transformation function to be less than or equal to 0, okay, as we see in the last video, okay? So there's nothing different. Okay, so, but this is still pretty abstract, right? So we want to directly visualize this problem, okay, as we did before in the consumer theory. So now let's have a little figure. Let's, for example, we have two goods. So y1 will be the input and y2 will be the output, okay? Just for simplicity. You could have more than one inputs, but that'll be a higher dimensional figure, right? So here, let's say our capital Y will be a set under this curve, okay? Let's suppose all those areas below this curve will be this capital Y, okay? So what is this? So that is Y, okay? Now we have this. So what is this P in your product Y, okay? And if you see this, if you can just transform, or you can just convert this into this scalar format, okay, then that'll be simply the summation of P times the Y, okay? So here, what is that? So that'll be simply, for example, P1 Y1 plus P2 Y2. That'll be just a straight line in this space, two-dimensional space, right? And for example, let's denote this as just pi, okay, profit. Okay, so that'll be just some straight line, right? So what's the slope of this thing? So we want to write this in terms of y2, right? So that'll be pi minus p1 y1 over p2, right? So the slope of this straight line, that would be negative p1 over p2. So we already assume that those are positive prices, right? So this slope would be a negative thing. So that'll be just some straight line with a positive, perhaps negative, right? We don't know, with some intercept. Okay, so that'll be just some, okay, some downward sloping straight line, okay? So that is our prices, okay? Or this profit line, indicating the prices, okay? So using the slopes, right? Using the slopes to indicate the prices, the price ratio, exactly. So that's very obvious, right, from here. So we want to maximize the profit, okay? So we just try to move this red straight line as far as we can upwards, right? So we know that this could be somewhere here, but we have to let this y to be able to produce, right? So that'll be element inside of this blue area, okay? So that'll be exactly some line tangent to this, okay? All right, so this point will be exactly this solution to this problem, right? Okay, so that is PMP, all right? Good. So, but let's have another example. So that'll be, if you remember the things we discussed last time, so that'll be a example where we have this capital Y to be, so this would be a decreasing or non-increasing return to scale, right? Because we're gonna have this decreasing rate of this. So that this looks like a concave function, right? So going this to the left. So what if we have something, okay, which is not non-increasing? What if we have something, for example, the y, we have exactly something straight, okay? Or even worse, we have something like this, okay, for example. What if it is straight? Then if the prices are such that it has some slope, okay, for example, as this, okay, then we could always increase, or we can always move this red line upwards, and it can intersect with the set of capital Y all the time, right? Because we can just extend this forever. So this simply means that there's no, there will be just some infinity as the solution to this problem. So that means that there will be no feasible solution to this problem. Okay, good. So that would be just some special case. Okay. Okay. Good. So that's the first problem that we introduced for the PMP. Okay. And okay, so the next we're gonna also introduce the properties, okay, that we have for this profit function. Okay, so before that we're gonna define this profit function. Okay, so given a production set Y, so the profit function pi of P that is associated to every price P is that'll be just the maximum of P inner product Y, where this Y is in the production set. Okay, so that would be the value of the solution to the PMP if we have this value. Okay, so that we can obtain this maximum. If that is infinity, then we have to use a supremum to denote the bound for this set, right? Okay, good. So, and also we can define the firm's supply, okay, supply correspondence, and the same as before, we have a correspondence here because we might have multiple solutions, right? If we have two, yeah, it's just possible, right? At P denoted by YP, that'd be the set of profit maximizing vectors, YP, okay, so those Y's are such that this is exactly the value, the level of this profit, okay? Good. So, okay, so that'd be the definition that we all need to move forward. Okay, so and we know that when this capital Y corresponds to a single output technology, okay, with differentiable production function fz, then we can view the firm's decision as simply one choice over its input levels z. Okay. So, well, Y corresponds to a single output technology with differentiable production function fz, then we can view the firm's decision as simply a choice as a choice over the input level Z. Okay, so this would be a special case, right? So that would be just a single output technology. Then we're gonna add a scalar. So now this will not be a vector, right? So this is gonna be a scalar P to denote the price of the output. Okay, and a vector W for the input prices. Okay, then we're gonna rewrite this problem. Okay, so the input Z, this will be vector also, maximizes profit given P and W if it solves this maximization problem by choosing this Z. And here this would be just a scalar, right? And Z is vector, but after going through this function, then product function, that returns one single output and minus the cost. That would be the input price multiplied by inner product with all the inputs. Okay, good. So that's just a special case of this PMP. Okay. And if Z is, let's say if Z star is the solution, okay, then we have some first order conditions, or from the conditions that we derive from the Quinn-Tucker conditions must be satisfied for all the dimensions from 1 up to L minus 1. Okay. And from FOC, we're gonna have P times the partial derivative of Z star with respect to ZL. That's gonna be less than or equal to WL with equality if ZL star is positive. Okay. All right, so the marginal product of every input L actually used here with this positive level of ZL star, it must equal its price in terms of output. That would be WL over the P, okay? And also we can notice that for any two inputs L and K with positive levels, then using the previous conditions, then we have this marginal rate of technological substitution, right? So that would be just the rate of WL over WK, okay? Okay, so you can refer to the textbook for further reading on this part, but we're gonna just skip this pretty fundamental and straightforward things, okay? Good, so that'd be a restatement or some special case for this PMP under one single output case, okay? So next, we're gonna go into the proposition of 5.C.1 where we have, where we're gonna introduce all those properties that is satisfied by the PMP problem or the profit function, okay? So we suppose this pi is the profit function, okay, of the production set Y, and we have this Y is the corresponding or the associated supply correspondence. Okay, so that would be just the solution. So we then assume that this capital Y, okay, also suppose that this Y is closed and free, we have, and with free disposal property. Okay, good. So the number one property All of those properties we are very familiar because we might have seen a lot in the consumer theory, right? So we're gonna follow the textbook and go quickly with those properties. So the first one is gonna be this profit function y is homogeneous of a degree 1. Okay. And second, this profit is convex. Okay. And third, if capital Y is convex, then this Y is all those little y's where we have P unit product Y, and that's now equal to the profit for all P positive. Okay. All right. And number 4, this solution Y is homogeneous of degree 0. Okay. 5, if capital Y is convex, then little y of P is convex. Okay, for all P. And furthermore, for this, if capital Y is strictly convex, then YP is single valued. Okay, exactly as before, as we studied in the consumer theory, right? Okay, and number 6 is called Hoteling's lemma, but it's also familiar with something before. So it's saying that if YP bar consists of a single output, then pi profit is differentiable at P bar, and the gradient or all the vectors of the partial derivatives of pi P bar, that'll be exactly the YP bar. Okay. 7 is that if little y is a function differentiable at P bar, then the total differentiation of YP bar, that'd be exactly, we take twice differentiation with respect to for this pi of P bar. Okay, because we have this, right? So if we take a further differentiation, then we're gonna take twice on this, right? So that's gonna be a symmetric and positive semi-definite matrix with dy P bar times P bar to be 0.